Everyone, so I'm just carrying on talking you through a new study on autism subtypes, and I just outlined in the other video, the 4 subtypes they've identified. The study says that most studies hunt for single genes. But this research zoomed out to find distinct genetic groupings. They asked, what kind of autism does this child have? The broadly affected group carries the highest number of damaging de novo mutations. So de novo mutations are not inherited from either parent, they're just spontaneous mutations that arise in a child. Yeah, genetic changes that pop up spontaneously. You know, so there might not be a genetic history of autism or anything. These changes just pop up randomly in a child and can have quite extreme effects, potentially. They might, by the way, also have inherited genetics. This doesn't mean that I read also that it's also possible for a child to have de novo mutations alongside an inherited variant, which will make their autism even more extreme. So it's possible to have both as well. In contrast, children in a mixed ASD with developmental delay group are more likely to carry rare inherited variants. In other words, they will inherit these from their parents, but they're rare, they're not common, and they tend to be passed down quietly through the generations. So there might not be any immediate autism in their family necessarily, but there are these genetic traits that are just passed on quietly, a bit like that aren't really kind of making themselves known, you know, that are sort of latent and just passed down through the generations. And they're not that common and they're quite rare. And then all of a sudden this child then expresses them. Whereas those in the other 2 groups, moderately impacted and the social and behavioural challenges, are more likely to have the common genetic variants that are kind of inherited from their parents. But as I say, it is possible to have rare de novo mutations. So it is possible to have de novo mutations, rare inherited variations, and the common ones. They're not like mutually exclusive. This is just a kind of very crude kind of differentiation. Another thing is that in previous studies, most autism-related genetic changes were thought to happen before birth, but this actually wasn't always the case. For example, in the social and behavioural challenges group, showed mutations in genes that activate later in childhood. And these kids often hit early milestones like walking and talking on time, but face social and emotional hurdles as they grow. So autism is usually diagnosed later. So that would explain why, say, some children, like, they might appear to be completely typical as babies, because the genes haven't activated yet. And then as they get older, like, say, maybe like in late toddlerhood, they might start showing anomalies, and then it gets more obvious as the child gets older because more and more genes become online, if you like. So you might have a baby that appears to make eye contact, that appears to interact and everything like completely normally, and no one thinks autism because it just seems like any other baby. And then as the genes come online, as the child gets older, say late toddler, maybe like 2 or 3 or something, the parent might start to notice things that aren't quite right, and they probably can't put their finger on it because it's often quite subtle at that age. As these genes come online, and also as like social interactions obviously become more complex and more demanding, and the child can't keep up, and then the child's autism starts to become obvious because they're lagging behind their peers socially, whereas they weren't before. Because obviously before, socialised, the child could do the most basic social stuff like that babies can, but as they get older, the autism starts to become apparent. Whereas obviously in other autistic children, the autism can be apparent really, really early, like even in babyhood, but that isn't always the case. So it can depend when these genes start to become activated, and that suggests different profiles. While the current work defines 4 subtypes, as I say, it doesn't mean that there are only 4 classes, there are at least 4. At least 4. Yeah. What I would like to know, though, is how all of these how the genes interact with epigenetic environmental processes. For example, it's well known that certain events like intrauterine events can raise the risk of autism, and prematurity and birth complications and those sorts of things are known to be a risk factor. But only if there's already a vulnerability there. You have to have a vulnerability, So there has to be a vulnerability, but it's not clear to what extent these events actually trigger the autism by causing a genetic cascade, or whether the autism is already there but they're just kind of worse than the autism that was going to be there anyway, or whether even the very fact the child's autism itself might have even caused some of these events. Like there is an argument that if a child's autistic, that can in and of itself increase the likelihood of prematurity because the baby isn't cooperating with the mother. So there's lots of different theories as to this. Why is this a case? But yeah, this epigenetics, like how genes interact with environmental risk factors. This needs more research, because it says like with the social and behavioural conditions group, the genes might not necessarily come online until the child's older, which is why the presentation tends to not be obvious until the child's a bit older. But I just want to know what impact, say, intrauterine events, if there's an intrauterine event, how that might influence this. Because clearly the intrauterine event has happened before the child's traits become obvious, so it must already have had effect. And just get whole nuances of that. I just want to know. It doesn't really explain that in his article, so I hope there'll be more research into that. Okay, so do let me know what you think, and thank you for watching.